Hi, Al Williams here with Hackaday. I wanted to talk to you a little bit about the GNU Radio Companion, and it's kind of a misnomer because it's got the word radio in it, and granted, usually when you're using this you want to do some sort of software-defined radio project, but it's really more like the GNU signal processing companion. It would be a more accurate way to describe this because in fact you don't have to do radio things with it. You can just process general signals, some of which happen to come from a software-defined radio. I will get to the software-defined radio part in part 2, but the first thing I wanted to do is just sort of introduce GNU Radio Companion and give you some things that you could try even without any specialized hardware, just so you could get familiar with it. The entire system's based on Python, but unless you want to do something exotic, you don't really need to know anything about Python to get this to work. It does help if you know a little bit about how to construct certain syntax and formulas and things in Python, but frankly it's about the same as C or C++, so it's a good bet you know it anyway. It's a pretty straightforward program to use. You can see it's very simple looking. There's a window here with a couple of blocks. That was already put in for me, and I'll talk about that here in a second. And over on the right, there's a bunch of interesting looking palette entries like audio and digital television and error coding and filters and Fourier analysis. So great fun to look at those and wonder what some of them are. There is help and documentation, and we're going to use a few common blocks. We won't cover every single one of these blocks because if you realize these all blow up into even more blocks, right? So that's really just the top level organization. So there's lots and lots of choices here. NOAA weather satellites and synchronizers and trellis coding and just all sorts of interesting things. So for right now we're going to do a fairly simple example. Let's look at these two blocks that are already here. One is the options block, and I'm going to double click on it. And this is going to be where you do most of your work, is in these property dialogs. You can see it's called top block. There's a title and author. I'm not going to bother filling all that in. There's a window size, and there's some generate options. We're going to generate graphical user interface elements, and this is a cross-platform program, so you can use the WX or the WX widgets, I think is what they're called now, the WX GUI, and that's probably a good choice for Windows. It does work under Linux. Or you can use Qt, which is the obvious choice under Linux, and in fact works under Windows. So this is really kind of your choice. Or you can tell it you don't want any GUI at all. I'm on Linux right now. In fact, I'm on KDE, which uses Qt. So I'm going to tell it I want Qt GUI. And that's really important because when we go over here and start picking user interface elements, which are just some of those blocks, they'll give you the choice of whether you want Qt or WX. Good news is it's pretty much the same items available more or less for both systems, so it almost doesn't matter. It's just whichever your preference is and whatever's installed on your system, obviously. So I'm going to click OK there, and it also gave me a variable. And variable, not very exciting. It's just some name and some number, and that happens to be our samp rate. And it's set automatically to 32,000. This has to match your hardware, and so I'm going to change mine to 48,000. And there's really nothing magic about this. It's just a variable, except most of these blocks will automatically use that number as their sample rate. And I'll show you what I mean by that here in a second. So let's try something just really, really simple. I'm going to go to the waveform generators item down here. And there's a couple of things here. By the way, if you wanted to not have to know exactly where those are, if you come in here and press Control F, you'll get a little search box. And so if you wanted to find, say, filters, you do that and it'll kind of narrow that list down. In my case, I just happen to know that what I wanted was under waveform generators, and I want the signal source. So I'm going to drag that out here. There's a couple of things to notice. You notice it's in red. That means there's something wrong here. If everything was okay, it'd be black. Well, what's wrong is there's nothing coming out of this block. The other thing to notice is there's a blue little nub here. That's the connection point, and that blue color tells me the data type. And in this case, I just happen to know the data type is a complex type. But you'll see there's other data types, and complex doesn't in this case mean complicated. I mean complex number is a number with a real and an imaginary part. And you can see it says the sample rate's 48,000. The waveform's a cosine, the frequency, the amplitude, and the offset. Well, that's not really 48,000. What it is it's that sample rate. So let me show you how I know that. If I bring up the properties, again, I double-clicked on it. The sample rate is set to samp rate, and you'll notice that's the same as the ID of that variable. So if I had changed this to, 44.1 kilohertz, then that would have changed all the blocks out here on this diagram, in this case just this one, but that's because it's the only one we have. It would change it to the right sample rate. Now, if I wanted a specific sample rate for this block that wasn't that sample rate, I could hard code it in here, or I could pick it up from another variable, or, you'll see this in a little bit, you could pick it up from a GUI element. So you could have a slider or drop-down box, those kind of things. So in this particular case, we've got a cosine waveform. I think I'd prefer a sine, but it doesn't really matter. And you see you've got other options like squares, triangles, sawtooth. And you'll notice that's really a number. So if you look in here, let the mouse float, it'll say that the sine is 101, but like the cosine was 102, and the square wave is 103. So those names are just handy, but the numbers are what's really important, and remember that because we're going to take advantage of that later. And let's just leave it at 1,000 hertz or 1 kilohertz, and the amplitude's 1. That's fine. And you can see I mentioned that the red title here said there was a problem, and that problem is right here. Port is not connected. The signal source is going to generate stuff as fast as it can, even with a 48 kilohertz sample rate, and on my computer that's a lot of operations per second, and it'll make the computer kind of sluggish. So I'm going to go to the miscellaneous here, and I'm going to pull out a throttle block, and that throttle block will just say, look, I don't care if you can do this more often, I only need it 48,000 times a second. So that's going to be our first connection. Doesn't matter which of these nubs I click first. I can click this one first, then that one, or I could have done it backwards. But it does matter that the colors are the same. And again, that's that complex data type. And so you can select everything and drag it around. It's just kind of the typical GUI sort of thing. The next thing I want to do is I want to go to instrumentation. And here we go. You've got your choice of QT and WX. If you pick the wrong one, if you've got the option set for WX and you pick a QT block or vice versa, you'll get a cryptic error message and you'll have to figure out why that was. So just remember what you picked. It's QT in our case. And I'm going to take a QT, let's say a frequency sync, and bring it over here. The QT GUI sync is really clever, and it's got a lot of tabs where you can pick like an oscilloscope view and a lot of different things. And you'll notice if you let your mouse float over, it does give you some description of most of these blocks. Sometimes they're a little hard to read from how they're formatted, but it's better than nothing. So you can see both those blocks have a problem because they've got the red. They both picked up the sample rate. Well, the reason they're both in red is because they're not connected. So I'll click here, I'll click there. Notice I did it backwards that time, and that's fine. Now everything's black, so that's good. And we could actually just go ahead and run this. I'll bring up the frequency sync properties first. You can see it's going to do a fast Fourier transform on complex data. It's going to do 1,024 points. There's a window type. If you're familiar with FFTs, that's the window function that gets the input data from at the edges. I can change the center frequency. I can tell it I want a grid. Let's do that. I can tell it I want auto scaling. Yes. Whether or not I want averaging, the update period, all these things. There's also a GUI hint. I'm going to come back and tell you more about that in a bit, but just keep that in mind that there's this GUI hint that's going to help me arrange things on the screen. Right now I'm just going to leave it blank. So I'll need to save that, and I'll just call this HAD test. And there's a little play button here. You might expect that'll execute, and it does. And let me resize that just a little bit so it fits better on the screen. It's kind of, because it's auto scaled, it's kind of large. You can scale it back up. So the noise at the bottom, there's our 1K spike, more or less. If you blow that up, you could get good enough resolution to see it's really 1K, and then it kind of rolls out. You can right-click to reset the scaling. You can see the auto scale's kind of making it jittery. You could turn that off. You can look at the minimum and maximums and hold them, which for this would be pretty boring because it's always basically the same. So pretty interesting, just a couple of blocks drawn on the screen here, and I've got a FFT of the 1 kilohertz. That's a little boring because, you know, it's a sine wave of 1 kilohertz and it makes one spot there. So let's try to make it a little more interesting. I'm going to close that top block. And what I want to do is I want to be able to vary the frequency of this signal source. So if you look, there's a GUI widgets folder here, and under QT, I'm going to pick a QT GUI range. And that's going to put a slider on the screen. Now I want to call that slider, let's say UI FREQ, UI frequency, and my default value is going to be 1000. I'll let people go down to say 10 Hertz, and I'll let them go up as far as I don't know, 100 kilohertz, and we'll step by tens. So that'll make it kind of annoying because it's a long range, but that'll let us do a lot of changes. Again, note the GUI hint. I'm going to leave it blank for now, but just remember it for later. And you can pick the style of it too, whether it's a counter, a slider, a knob, a thermometer. I'm going to go ahead and leave it at the default counter and slider. Now, you'd like to think that there's some way to grab a little button here and drag it and get a little connection over to here. It just doesn't work that way. The connection's going to be because the variable's UI freak, just like samp rate connects all these blocks to that block. This is just about like a variable, but it's got a GUI in front of it. And so when I bring up the signal source properties by double-clicking on it, I'll have to change the frequency to be UI FREQ. It's really easy to forget to do that. You'll set up your GUI, you run it, you say, well, gee, that doesn't work, and it's because you forgot to connect them by putting the variable names in the right place. And you'll notice it still says frequency is 1K there, just like the sample rate shows up at 48K, because it's actually interpreting those. But you bring up the properties, you can see, no, it's really a variable, and the numbers just are what the variables happen to be at the moment. So let's see how that works. I'll save it. I'm going to do a run. And there's my slider. And there you go. As we increase the frequency, you can see the spike from the sine wave. And then we'll decrease it. And it does what you kind of expect it'll do. Obviously not a lot of control here because it just happened to put this first and that last. I'm not sure what algorithm it uses, but I'll show you in a minute how you could control that and get the results you want. In this case, this actually looks okay, so not a big deal. Let's say that we wanted to change the type of wave, though. You've got a sine wave now. Do you remember we said that was 101 and 102 was a cosine wave and 103 was a square wave? So let's take a QT GUI chooser, and I'm going to name it, I don't want to name it that, I'm going to name it UI sig type. And I'll tell it I want two options. The default value is 101, which is the same as option 0, and that's sine. And then option 1, I'll make 103, and we'll make it square. And I'll leave it as a combo box, although you could do it as a radio button. And don't forget, you have to go connect it. So UI sig type needs to be in this box now. UI sig type. Okay, so I'll save it. I'm going to run. And now at this point, I've got the UI sig type here. I can change it to a square wave. I can change it back to a sine wave. You know, all this works like it used to as far as the frequency. But this isn't really very pretty, right? I probably should have given them nicer names. But also just the way they're stacked. So if you remember, I mentioned that there's the GUI hint. And so it allows you to do 2 or 4 numbers in there. And it's just rows and columns numbered from 0. So if I wanted to have, say, one row that had the range and the chooser in it, I could do that. I can say, let's go here and say I want the chooser to be in row 0, column 0. And I want the range to be in row 0, column 1. And I want my frequency sync to be on row 1, column 0, but I'd like for it to span 1 row and 2 columns. And so you'll see the effect of that here in just a second. So you'll notice here's my type, here's the frequency, and this actually, that stretch, that span, tells it to say, yeah, there's 2 columns here, but I want you to go over both of those columns. If I hadn't have done that, it would have either squeezed that into this column or made the column bigger probably, or it would have put it over in the other column depending on where I told it to go. But since I told it to go here but to stretch over 2 columns, I get this pretty nice result here. Okay, just to show you one more quick thing. The nice part about this is so far you didn't need anything other than GNU Radio to get this to work. I'm going to go up here to the top, and there's an audio folder, and I'm going to tell it that there's an audio source here. And that has a little orange nub there. Now why is it orange? Because it's not a complex number coming out of there. It's a floating point number. And if you go here, you'll see that there's no way to change that. Now some blocks will have a way to change it. So you can say, oh, I want complex or I want float. For example, the signal source. Right? Output type is complex, but I could make it do floats or integers or shorts, whatever I wanted it to do. Well, the sound card is pretty much going to be locked down to float, at least my sound card is. I know like my SDR radio is not. I can have it put out floats or complex. So I need to connect this somehow, and I'd like to be able to select. So what I'm going to do is I'm going to cut this out. Notice everything goes back to red because things aren't connected. And I'm going to go into my miscellaneous, and there's a selector. And I'm going to tell it that I want 2 inputs. I only need 1 output. The type's going to be complex, which is okay. And you'll notice this input index, output index, that's going to pick which input and which output to use. In our case, the output's always going to be 0 because we only have 1 output. It's easy enough to connect these 2 and connect these 2, but the problem is I've got the orange and the blue I/O ports here. So I will need to go and find the converter for that. And there's a type converter that can do a float to complex. And nicely enough, it's got orange ports on the left and a blue port on the right. And all the red just went away. Now, this obviously isn't a very good design to have this selector with an input index hard-coded to 0, because it means it's always going to pick this one. So clearly, I need, say, a chooser, or you could probably do it with a checkbox. I'm going to just do a chooser again since we've already done that. And so it's pretty much the same setup we had before with just different numbers. I'll say the default value is 0, and for 0 you have sound card, and for a 1 you have test signal. And let's see, probably want this in row 0, column 3. And that means I probably should go make the frequency sync stretch over 3 columns instead of 2. And remember, UI select, that's how we're going to attach those. So the input index now is UI select. Okay, let's see if I manage to do that without making a mistake. We'll go ahead and run it. And sure enough, well, looks like this is not stretched out the way I thought it was. I'll have to look at why that is. But I can go in and do the sound card. And let's see, the sound card right now is capturing from a different source than I'm recording on, so you can kind of see if I can get a good pitch here. You can see those spikes when I whistle. Or I can go back to my test signal and it's like it was before. So this kind of illustrates one of the downsides, though, is because the GUI isn't really done graphically, just the data flow. Sometimes it's a little hard to work out your GUI exactly the way you want it to look. So if you notice, I had the range set as 0, 1, and I had the chooser as 0, 0. So these are 0 based, so that means this is going to be first, then this. But what did I do in the GUI chooser on this one for the select? I did 0, 3. That should have been a 0, 2, right? So I actually made a blank empty column by accident. And now that should in fact span 3 columns. As before it was doing 3 columns, but that third column was just an empty, very narrow column, and then there was still a fourth column, which was number 3 that this chooser was occupying. So let's see if that theory is correct, and there you go. Now the FFT window is covering the entire piece. So just a couple of simple blocks. We built a pretty interesting example. To go back over it, the options let us set the GUI type. The variable let us set the sample rate that controls the whole rest of the diagram. We've got a range that lets us pick the frequency. We've got a chooser that lets us pick the type of the signal source, and we've got a chooser that lets us pick between the signal source and the audio source thanks to the selector. The throttle keeps the sample rate out of the source correct, and the audio card, by the way, doesn't need that because it already generates data only that quickly. But we did need to convert the float to complex before we ran it through. Obviously, we could have chose to make everything as a float, and then we could have just changed this to a float, and everything else could have been a float. You could have gotten rid of this. But it just depends on what data type you want to handle and whether or not you need complex frequency to do the kind of decoding that you want to do later, or whether you need floats. So it's pretty simple. The complexity is when you start getting into doing really sophisticated things with it, but just for getting in and getting a signal in, clearly there's also a audio source, so we could have put all this out to the speakers. I didn't want to do that because then I get feedback when I'm got the audio source as the input also. But for example, we could have routed out to the speakers and heard the signal source. There's wave file sync and source, so you could pick up a file and process it, or you could write your results out to a file. It's pretty simple to get that kind of stuff set up, and it's really easy. If you need something really complicated, you can either write your own blocks in Python. There's a way to get into C and C++ with that as well, or you can just write code. And none of this is something that couldn't be done without using GNU Radio Companion. It's just so easy to make these flows up and get everything working instead of having to tie all this together in code. Just the same kind of way you might build a GUI with a GUI editor instead of writing a bunch of code to create widgets and size windows and all that sort of thing. So part 2, we'll talk about actually doing some radio work with this, which will be fun. But for this part, I think we're wrapped up. Make sure to read the companion post on Hackaday and look for part 2 shortly. Thanks for watching.